So let's do some examples. The standard deviation of the age of college students is known somehow to be 2.2 years. This is based on our experience. We've been dealing with this data for a long time, and this is a good guess, okay? Maybe our good guess is even really a little bit lower, a little shy of this, like 2 years or 2.1 years. Then in reality, what you might want to do is just sort of be a little cautious, round it up a little bit. That'll bump up your minimum required sample size, but at least you know that you will take a large enough sample if you do that, okay? But anyway, let's assume that we have this good, solid ballpark estimate for the standard deviation of the age. What's the minimum required sample size to make a 95% confidence interval for the population mean age, mu, if we want an interval of width 1 year? All right, and be careful here. The interval is to have width 1 year. That means the margin of error is going to be 6 months or half a year. Okay? Tell you what, first thing I'm going to do is write down my formula. My minimum required sample size in this case is, remember, it's ceiling function. That's what this thing is, the ceiling function. Take the number to the ceiling. It's that z sub alpha over 2 number times our good guess for sigma, or the margin of error, like so, and I'll square all that business. There we go. Now I'll just fill in the numbers there, right? Let's see, we wanted a 95% confidence interval. Maybe I'll just do it all right here. INV norm 0.975. Remember, the way I arrive at the number that goes in the argument there for the INV norm function, the way I arrive at that number is to go halfway between the confidence level and 1. So halfway between 95% and 1 goes right in there in the INV norm function, times our good guess for sigma, which is 2.2 years, okay? Divide that by, it's our margin of error. It's half a year, okay? Square that, take the ceiling. You can see, of course, that my years are going to cancel, which is good because what you want to wind up here with in the end is just a number here. So I'll pull out my calculator and I'll do, let's see, get that INV norm function. There it is, INV norm of 0.975. Okay, I get that number and then multiply that by 2.2 and divide by a half. And then square all that stuff and then take it up to the next largest integer, right? So it's the final answer is 75, right? 75. Okay. 75. Great. That's easy, right? Let's do another one. How about one for proportions? How many students do you need to survey to get a 98% confidence interval for the proportion who smoke? If you want a margin of error to be, say, 3% or 2% or 1%. Okay, so let's do this for 3 different margins of error here and compare. 98% confidence, margin of error 3%. All right, well, let's try this. So first of all, let's write down our formula. In this case, we have n equals, let's see, what do we have? If we have some good guess for the true proportion, we can do it like this, times z sub alpha over 2 over the margin of error, okay, squared. Or if we don't have a good guess, then we just use the worst case scenario, in which case PGG is a half, and so you get a half times a half there, and all that stuff just reduces to a quarter then. Okay, that's the worst case scenario. Ready? So I'll tell you what, let's try the first formula first there. Let me just move this one. Let me just move this one down. What if we have a good guess? If we have a good guess, do you have a good guess? What proportion of students smoke? I don't know. It's probably something like 15-20%. Maybe let's go with like 18%. Let's be a little cautious here. Remember, in order to make the best interval we can, to make sure that we get this interval of a certain quality, we need to make sure we take a large enough sample size, which will increase in as p gets closer to a half. So if I'm thinking it may be 18 or 20%, let's take like 25%. Probably not 25% of people smoke around here, but let's take that just to be cautious. 25% times 1 minus 25%. Okay, and then let's see, what's our confidence level there? 98%. So this will be INV norm 0.99. Divide that by the margin of error. We want 3 percentage points, like that. Start off with, square that, and pull out my calculator. I get quarter times 0.75 times INV norm 0.99. And actually, I'm going to want to square that INV norm stuff, right? So let me insert, second delete is that, see that INS there? That's for insert, insert a parenthesis. come on over here and divide this by 0.03, square that, and there we go. Remember to round up to the next largest integer because 1127.47 is not enough. So that means 1127 is not enough. So we need 1128. Okay? See how I did that with my good guess there? Now, what if I don't have a good guess? Then I would use this formula, okay, if I really have no idea. Let's see how much this changes things. I get a quarter, that's just part of the formula. Again, that INV norm function of 0.99, 0.03 is our margin of error. Square all that stuff, and what do I get? Well, maybe I'll just borrow from what I had before. In fact, it's almost the same, right? Except I just need to delete that 0.75. Okay, just got a quarter times that INV norm stuff. 1504 is what that rounds to, 1504. Remember, you always round that guy up, 1504. That changed by a few hundred, didn't it? 300 or so, a little under 300, 400, 400. Okay, so it's definitely different. So that's the cost of not having a good estimate in advance there. Okay, now let's see what changes, how these things change if, what if we change our margin of error there to 2%? We change our margin of error there to 2%. I'll just go back into here and get what I put in there, right, 2 times ago with that quarter and 0.75 stuff, right? And just go in there and change the margin of error to 2%. Whoa, look at that. It jumps up and more than doubles, right, over the 1128 number, 2537. Okay, maybe I'll color code these. So this, and the blue stuff is E equals 3%. Red stuff is where the margin of error equals 2%. And the green stuff, this means the margin of error is 1%. Where's the green stuff? Oh, it's right here. Let's change the margin of error to 1%. Okay, let's see what happens. Go back in here, change that margin of error to 1%. Holy smokes! 10,148. 10,148. So you can see that there's quite a cost associated with shrinking our margin of error, right? We like small margins of error because they reduce the size of the interval. We like small intervals with high confidence levels. To get a 99% confidence level, and you even have some kind of an estimate about the true proportion, and you want your confidence level is this high and this small of a margin of error, that's going to cost you quite a bit. It's going to cost you quite a bit. 10,000. What do you do when your boss tells you to go take this survey? You say, "Look, boss, we only have about 10,000 students at Austin Peay State University. You're effectively asking me to take a census. This will take months." And your boss says, "Well, okay, you know what? Maybe let's back off on the margin of error there, and maybe we'll settle for 3% and only for 3% margin of error, and maybe just survey about a tenth of the student body, and maybe that would result in a more feasible plan for carrying out." So that's what we do. We bump into our capacity constraints when we're trying to solve a problem. Let's do the same thing for this method. Again, this method is going to result in even higher values of the minimum required sample size because we're less certain about what the true proportion really is. So again, let me change this to 2%. Okay, I'll pull out my calculator. I've got a quarter times, well, actually it's almost the same as the stuff I had previously, right? I just need to get rid of that 0.75. Change the margin of error to 2%. Whoops, I did something wrong. That's way too small. Let's see, what should it be there? Quarter times INV norm. Yeah, see, look at that. I got the wrong margin of error in there. 21%. That should be 0.02, like that. Okay, yeah, 3383. Okay, 3383. Of course, you see it's increasing as we would expect. Having a smaller margin of error is costing us in terms of sample size. Let's try it again. And remember when we went to 1% in the previous case, when we had some suspicion about the true population proportion, it resulted in just over 10,100 students. This is going to be even more, right? Yep. Holy smokes, look at that. 13,530. That's how that rounds. 13,530. Yeah. These things get expensive pretty quick. Notice that they're not increasing linearly, right? As we drop, down in increments of, say, 1%, this jumps from 1,500, it more than doubles here to get to there, and then from here to there, that's like 4 times as much. Okay, it's because we're squaring this quotient here. We're squaring it, so it increases very rapidly.